Right, we're ready to print our design. Our Canon laser printer. There we go. Right, let's cut the copper board to size. Right, shall we see how it's turned out? Right, it's looking okay, isn't it? Right, I'll clean that up and we'll drill it next. See that? Okay, next stage is ready for its dip in the solution that removes all the copper that's remaining. Right, should take about 20 minutes. This solution's very old, I've had this about 18 months, maybe 2 years. Amazing how long this lasts. Right then, I'll see you in about 20 minutes. Well, it's been in there for over half hour. Takes a bit longer than it used to now, this stuff's worn out. I'll have to replace it soon. Right, looks okay, doesn't it? That'll do nice. Right, we'll clean that off and sand the toner off. Great. Well, here's the parts list. How many parts? I think it's 22 parts. There are 9 caps. Resistors. Battery connector, the antenna, the audio connector, and your trimmer. 1 coil. 1 single transistor. And a tie there just to tie the wires up. There we go. Very simple. Put it together, shall I? Well, what we're going to do first is install the resistors. What I'll do is install the parts, and I'll solder them after. Makes the job a bit quicker, you see. So, first 48k, this is R1. 48k. I'll try and keep the camera in focus, or the camcorder shall I say. Here's the first one. Right, second one is R2, which is also a 47k resistor. There we go. Alright, third resistor is R3, which is the 22k, which I believe goes just here. There we go. Fourth resistor is R4, also a 22k. I hope the picture's not too dark. There we go, there's 4 resistors in. Alright, R5 is the 39k resistor going to the base of the transistor. Sorry. Okay, that's 5 of them in. The last resistor is R6, the 100R. Now if you can't get hold of an 100R resistor, you can use a 470R, anything like that. Anything up to about 470 resistor. There we go. What we'll do now is solder them in. Okay, we're just going to solder in the 6 resistors. Not normally the way I solder, but it's what I've got to do when I'm leaning over my camcorder and various other things. But there's 6 of them soldered in. Right. Okay, next job is to solder in the 9 caps. What I'm going to do is start with the ceramic caps. I'm going to start with C1, which is a 1N. It doesn't take very long to do these. I could put one of these together in 10 minutes. If you're just starting out, like a lot of my subscribers are, there's no rush. Take you half hour and an hour a lot. C2 is also a 1N. Apologise if my hands get in the way. I know my nails are a bit long, but when you're working with electronics like this, you do need your nails. Right, that's the second one in. Right, C3 is also a 1N. Oops, just goes out. Okay, the last one in is that's C5, is it? C4, sorry. Oh no, what am I doing? I apologise for that. What we'll do, we'll install the last one in, which is C6, which goes just out. To do C7 next, which is the 10PF, which goes across the emitter and collector of the only transistor, which goes just here. Now this value is critical to the circuit, so you'll need this to be a 10PF, and same applies to the next one, which is C8, which is 33PF. Right, which just goes out. This is C8. Okay. Oh. To these one's got to go the right way around. Oh, is it focused? Is it? Yeah. Okay. Right, that was, oh god, which one was that one now? That was C5, I believe. Next one is C4. There we go. Okay, last one, which is C9, 47 UF. Now this can be any value from 1 UF up to maybe 200. It's only going across the battery just to keep the circuit tightish. Okay, that goes out. Okay, they're all in place. What we'll do now is solder them in next. Okay, next we're going to solder in the caps. Now when you do solder to these bare copper boards, just make sure you use plenty of this stuff, flux, because it don't half help. Alright, let's get them lighting. I think rocking a bit. That's all the caps in now, looking okay. Right, the next part we're going to install is the trimmer for adjusting the frequency. Goes in there. Make sure they don't touch. I'll get a bit close if you push them in towards each other. Plenty of flux. Oh, I should have held this down with the tweezers, but been lazy. There we go. Coil next. I should put the coil in, shall I? This is a 5-turn wrapped around a 3mm diameter drill bit. This will give a frequency range from about 88, 90 to 110, 112 megahertz. Now if you use a 4-turn coil, we'll get a frequency start about 75 megahertz and going up to about 105, something like that. Not the best way of soldering, but just showing you how easy it is to build a single transistor FM transmitter. Cool. Well, next is the only transistor we've got in this circuit. Now I build these with 2 or 3 transistors. You can put on a buffer or an amplifier stage on. But the way I'm going to design this circuit, I'm not going to tap the antenna off the collector side. What I'm going to do, here we go, is I'll be taking the antenna off the second turn of the coil. Now that keeps the antenna away from the highly sensitive transistor collector, making this circuit much more stable than if I'd tap the antenna off the collector. And what it does, I mean, you can pick this up, you can hold it in your hands, you can hold the antenna, you can hold the battery, and the frequency stays rock solid. I mean, it doesn't move at all. Quite amazing, really. For a single transistor circuit, it's amazingly stable, and that's because we're tapping the antenna off, like I say, the coil. Is it focused? Oh, not much left, is there now? next is our audio input. This is stereo input, but obviously a mono transmitter. They both end up connecting to the bass in a mono way. No, plenty of flux. Oops. Right. Not a lot left now, is there? Okay, only a couple of items left to do now. So what I want to do next is the battery connector. It's going to be tricky, this is. I need 3 hands to do this. So what I have to do is solder the tip first, which I'm not really not doing. It does the job. Okay. Focus. Antenna next. Alright. Last item now is antenna. Now, as I explained earlier, I'm taking the antenna off the second turn of the coil, which is just there. Let's zoom in a bit. Oh, wrong way. Right. So I'm going to take the antenna off this second turn here. Right, normally I would have a 10 PF. If you want full power, right, just put a 10 PF across here, and there's your output for the antenna. Right, so it comes from the transistor collector. The output, the RF output, comes across the 10p and out. Right, what I'm going to be doing, right, to make this transmitter a lot more stable. You wouldn't believe how stable it is doing it this way. But you lose about 40–50% RF power. I mean, if I do it the normal way, good for the 10pf, I'll get about, I don't know, 1,000, 12, 1,300 foot with using my car, you know, FM radio. Obviously it's going to be reduced using it this way, but that's the way I'm going to be building it for this video. Now I need 3 hands again, so what do? I'll try and I've tinned the coil, as you can see. There we go. It's got it nicely. Banging. All I've got to do now is tie the cables up with a plastic tie. Job done. Well, transmitter's all done now. Don't look too bad, does it? So audio input. You can take an input from your mobile phone, MP3 player, anything. Not bad soldering. I've done better. But soldering while working over a light and a camcorder and various other things is quite difficult. Still okay though, isn't it? Right, next we'll test it. Okay, after all that, does it work? Now you might have seen this on previous videos, it's my frequency counter. I've wrapped it around the antenna because I want to put it towards you. If we get a frequency, alright. Plug the battery in. Screwdriver to adjust. Okay, here we go. Oh, 97.5 megahertz it's saying. Sugar butchers. Something like that, 96 is it? 0.8. Well, I know that frequency around here is occupied, so what I'll do, I'll move that up to about 103.4, which I know is not used around here. That's it, 103.6, move it back a bit. No, that's too much. Well, that'll do, I think we're around about there. 103.2 is it? Should try and get on 3, shall it? Can be a bit awkward. Oh, that'll do, it's on 103.3. And bang on, so when it works. So what we'll do now, that's cool. Aha. About 103.4 that is, isn't it? Alright, now what I'll do, I'll plug some music in. It won't be anything you're familiar with for obvious reasons, for copyright laws on YouTube. Cool. Sounds good, doesn't it? Like I say, I mean, this leads, I think this leads about 15 foot. It's a big one. I've lost my short one. And you can see, there's no effect on frequency. And touch a battery. Wow. Look at that. As long as you don't touch the circuit that's oscillating. Yeah. Battery light. Still playing. Cool, I'll grab the antenna. Look at that. Still playing. I think the song's just finished. Unbelievably stable for a single transistor design. Look at it. You can hold everything. Oh, that's near the oscillator. Oh, cool. You're probably saying, turn that rubbish off, but like I say, I can't play any chart music or anything like that. Oh, back to that song again. Now we'll go upstairs and see if we can tune into a radio. Put the lid on. Didn't focus as yours. My car outside. Oh, box for my wine kit, making my own wine. My weights, not to get fit. My bike. Alright, here we go. Focus. That's a lot on focus. There we go. Just turn the light on, I'm not sure why that ain't focusing, it normally does. full signal. And build it yourself, not hard to do. Very simple transmitter, single transistor, 22 parts I think there were. If you've not subscribed to my channel on YouTube, please do so. It's the sort of thing I do these videos. Well, hope you enjoyed that.